Hi, welcome to the asynchronous, uncoordinated, continuous delivery of 35 plus microservices talk. Today I'm going to be talking about how we at Ocado have come up with a way that has allowed over 24 developers to continuously deliver their software into production without having to coordinate with all the other developers. Because as you can imagine, as teams grow and as your set of microservices grow, the more you have to coordinate, the more difficult things come. So we decided to not have to coordinate at all and come up with a way so that we can just do deployments without having to always worry about what is everyone else doing. The way we go about this is to try and put some good architecture in place, but today the talk is mostly going to be focused around development practices. But let's first look at the architecture. As with many technology choices, your architecture, when done properly, can be a great enabler of your practices. So the architecture we're talking about today will just allow you to be able to use the practices better, but doesn't necessarily mean you can't start with the practices immediately. The architecture that we think is good for continuous delivery and microservices is basically three things: stateless microservices, resiliency, and good fallback strategies. Stateless microservices. So this is one of the most popular form of microservices out there, and as you can see, I'll show you why, but stateless microservices have been very useful for the main reason: they make deploying simple, they make scaling up simple, and they make scaling down simple. And the reason for this is that each call to a stateless microservice only worries about that immediate call. It doesn't worry about the ones before, it doesn't worry about the ones afterwards. It's only concerned about that current call. So if you scale up and down, or if the call's done, subsequent calls are done on different servers, it doesn't actually matter. So it just really simplifies your deployment process. Also, if you have stateless microservices, making idempotent endpoints are actually much easier. So idempotent endpoints is really the ability to be able, if you make the same call multiple times to a given endpoint, it only actually has a singular effect. This is very useful when you come into like fallback strategies and resiliency, as you don't really have to worry about how many times has a call has been called before. You know, if this call has been made, it will only have the desired effect once. The best way of handling idempotent calls is to always have a unique ID generated by the client associated with that call. So if they're making that call multiple times, the receiving system knows that all these subsequent calls are related or should have been a single call. And the next important thing about our stateless microservices is we want them to be single responsibility. You want your microservice to be responsible for a given algorithm or a given piece of functionality, and any calls or any use of that functionality should only go through that microservice. What this allows you is to know whenever you're doing changes or updates, you only have to be concerned about one service in one area when making that change. You don't have to worry about, if I make this change, is somebody else that's dependent on this data or using this algorithm somewhere else can also be affected unexpectedly? No, because everything's coming through the single microservice. You have your contract, you have your interfaces, you know exactly what's going to happen. And it also allows you to do a lot of changes in the background, which everybody is unaware of, but as long as they get in their right data and the correct responses, they are happy. Also, along with single responsibility goes keeping your data local to your microservice. Having your data local to your microservice actually abstracts your data structure and data accessibility away from the database level. That means anybody who wants to access your data can only access it from the single microservice. And this is done via a contract-based API. So how you return your data has got nothing to do with the structure of your data or the performance of your data. And you can keep changing those sorts of things. You can change the structure, you can tweak it so your data is returned faster, but the calling system actually has no idea about that. They just get returned the data in the given format. The next thing is you want your microservices to be resilient. Just think, in a normal monolith system, if you have a system that has a 1% chance of something going wrong, and then afterwards you break that down into microservices, and next each microservice also has a 1% chance of something going wrong, and if you make a call and that call request runs through 10 microservices, all of a sudden the probability of something goes wrong goes all the way up to like 10%. And now that can be actually quite a bad thing. But in the world of microservices, what's actually happening is this gives you an opportunity to really think about the resiliency of your system and how well it operates. So taking this disadvantage, you can turn it into an advantage and build highly resilient, highly scalable microservices that will actually probably be more stable than your monolith, because you'll be thinking about this resiliency built right into your system. A good way to ensure that your systems are always resilient is to actually bake them into the definition of ready, and always be thinking about it when building it. The properties of resiliency we look for in a microservice, especially in relation to continuous delivery, is that it should be able to start up independent of all other services. So as we know, each microservice actually makes calls to other microservices, is called by other microservices, but we want our microservice to be able to start up all on its own, even if all of the other microservices around it aren't around. This is particularly important for our continuous delivery approach, as this means you can push changes and do deployments without having to worry about, are other systems up, are other systems working. You can just do that one deployment to your existing server. The next thing we try to do with all our microservices is to actually have no startup processes built into the startup cycle of the server. Yeah, we try very much to distinguish between a service level and server level. We try abstract everything away from the servers and think about it at a service level. So if you need jobs to be run, if you need things cached, and if you need processes run, you think of it as a service level. And the way this is usually done is by having things like queues, which you can place jobs on, and then the jobs on the queue, then any server picks up the queue, and then any results are, say, stored in cache, and then you keep your cache at a service layer, so using things like memcache and Redis, and that allows you to pull all those concepts and keep them at a service level. So when you bring up a new server or the system is scaled up, it doesn't have to worry about where do I get this cache from, is the cache instantiated, is it warmed up? It just pulls it from those externalized caches already. What this also allows you to do with, say, jobs and processes, you don't have to worry about master slaves, you don't have to have a single server that coordinates everything. It just, your service just says, is there job available, and then the first server picks it up in process, so you don't have to worry about coordinating all that stuff between your server pool. And the next thing, having all these things in place is no good if your services can't recover gracefully. So if you have a service that starts up independently and no other services around, you want it to start working properly as those servers come up. So you want it to recover gracefully and be able to detect that the service was down, now it's up, now I need to start working correctly. And having good recovery systems and good recovering gracefully actually helps a lot with your fallback strategies, which is what I'm talking about next. So as we said, the risk with failure in microservices increases a lot, especially the more calls are made and especially the deeper your stack of your microservices are. So we need to worry about how you handle failure, and this should be built in as a core feature of your system. Resiliency and fallback aren't just a secondary thought nowadays when it comes to your design. It's actually one of your primary concerns. So whenever you build in something, you should worry about your fallback strategies. What happens if something's not available? So basically, fallbacks as a feature. So every feature you build or you actually thinking about or designing, your fallback strategy for that feature should actually be thought of in the beginning, because there's no one size fits all when it comes to fallback. Each fallback is dependent on your feature. The only common thing about fallbacks is detecting that a fallback needs to happen, enacting the fallback, and then once the fallback no longer needs to happen, to start operating normally. So a good way to ensure that you always have good fallbacks is in your definition of ready for any feature or story, always ensure have fallbacks defined. Another useful strategy with fallbacks, especially around configuration services or data that doesn't change often, is to cache as much of that locally as possible. So what you want to do is, whenever you make a call to these configuration services, they always cache the response locally. So in case there's that moment when that service is down, like a configuration service, you don't want to bring down your whole system. But if it goes down, you just go back to your cached fallback, use that information, and then once those configurations come online, it can be updated to the latest service. You can even primarily work off the cache, and an advantage of this would be you actually increase performance of your system. Hystrix is a very useful tool when dealing with fallbacks. It's one of our primary tools we use. The nice thing with Hystrix is we get out of the box, or one of the best practices around detecting failures, recovering from failures, and being able to handle them, and how to gracefully recover from them. You get lots of best practices from Hystrix, like out the box. So I'd recommend going with one of these like proven tools and trying to build it yourself. So to sum up, basically our architecture is, we want an architecture that is very independent but collaborates well with all the other microservices around it. So it needs to be able to start up by itself, work independently, and then if something goes wrong and other services are down, it can gracefully fall back from it and then recover properly when needed. And also, you want your service to know if something goes wrong, you aren't going to break everything else. So if you know your service has this property and so do all your others, if something goes wrong, it shouldn't be the end of the world for your system. But a good architecture actually isn't the only thing that solves the problem of our uncoordinated delivery. It's just a good enabler of our practices. So before we actually go and talk about our development practices, there's just the little rant I'd like to go on that's quite important to me. I think when it comes to development nowadays in an agile and continuous delivery world, that people almost think of agile as undisciplined, uncoordinated, like development. We'll just do stuff when and if, and it gets delivered when it's delivered. But I feel it's actually quite the opposite. When you're doing agile and continuous delivery as a developer, you need to be more disciplined than you ever have, because you're no longer just having something thrown over to the fence to you and then you're developing it and throwing it over to the next person who's responsible for releasing it. Nowadays, as developers, we are becoming responsible for the entire development pipeline. We're responsible in helping define features, we're responsible for delivering the features, and we are actually responsible for deploying them and supporting them afterwards. So in today's world, developers need to be more disciplined than ever because we have a much greater responsibility. So me just talking about development practices aren't going to be any use to you unless you actually, in a disciplined way, follow your development practice and way of working, and then in a continual day-to-day manner, make sure you keep following these practices. So it's actually up to you if this is going to work or not. So after my rant, just a little bit of inspiration if I can help you with. In continuous delivery and agile world today, we're in a place where we can actually challenge all your current paradigms, challenge all your current ways of thinking, all your previously accepted practices of the way of doing things. So if we just look at Einstein, one of his great quotes is, learn from yesterday, live for today, hope for tomorrow. The important thing is to never start questioning. And that's what I want you to do today. Being agile, being continuous delivery, you should be questioning everything you're doing, why you're doing it, and you will be able, in a very powerful and innovative way, to actually overcome the challenges of software delivery today. So based on the architecture we think at Ocado we've come up with a very good set of practices that, as I said before, can allow dozens of developers to be continuously releasing almost 10 to 20 times a day, multiple times a day, to over 35 microservices, and we don't have to keep being in coordination with each other. So let's look at those practices. So for us, our development cycle is actually quite simple. All we do is we implement a new change or a backwards compatible change, we release that change to production, we then update other systems to use that change, and then after that we just keep following that circle. So we repeat that, implement change, update other systems to use change, and you just repeat until you've actually built up your feature. And once you're ready, you turn the feature on, make sure it's working, and then you go back and you do cleanup. So the process might look simple, but you actually need to be quite disciplined in a lot of the ways you go about this. So the first thing I want to talk about is actually the concept of decoupling releases from deployments. What I mean here is that when you actually deploy code to production, that doesn't actually mean you're releasing feature or you're releasing actually functionality. It just means you're pushing code out, but it might not actually be used. It could be just a new endpoint that's not been called by anybody, or it could just be a piece of new functionality that's hidden behind the feature flag that's not ready to be used, but it will actually be a combination of deployments before your feature's actually ready. So this to me has been one of the biggest mindsets to get people around. Pushing a change to production doesn't mean releasing a feature. But once you get this in place, it's actually quite very powerful in the way you go about building things and releasing features. Another thing is you want to keep your deployments as small as possible. So when you're releasing something to production, you don't even have, when you break stories down into subtasks, you can release just the subtask of a story. You can push that out into production. And the nice thing about this is, even though it might not be used, every time you're doing a release, every time the system's running, you're constantly having tests run against that. You know it's working, you know it's meeting your current testing environment, and at the same time you know your old way is working. So as you're building up your feature and slowly building up these new changes, doing these small releases, you always show your old ways working, and you're continuously building confidence in the new feature or the new change you're building. And also, the best thing about this, if something does go wrong, you have a very small estate you have to worry about, like where could have what gone wrong. You've only got your one small feature, your one small change that's been released to production, so you have one small area to investigate. And also, when your releases are this small, it's more likely that you actually won't have a mistake because you actually just focus on pushing out such a small change. And that leads me on to feature flags. For us, feature flags is very important in our way we do our continuous delivery environment, because this is what allows us to have backwards compatible code running alongside new code. And the important thing here is, if you have backwards compatible code, you can be continuously pushing out your changes, but everyone else, what they're working on, should still be working as expected, because the old way of working is still there. They don't need to be aware of your change until it's actually important, or they need to integrate with it. They can still keep working with the old way. So for us, feature flags are very important, and we have this built into the architecture of our system. So with feature flags, we're able to turn off endpoints, turn on endpoints, completely block out areas of our system. And with a single utility class, we're able to check if a feature is on or off. So this is, for us, quite important, and we've built it into our system. And the main way we do feature flags in a microservice architecture is we get all the features that are enabled for a request as early on in the process. We sign those features with Java Web Tokens to make sure they can't be tampered with and they can be trusted. And then we propagate that in headers. So if a call is 10 calls deep in our stack, that feature header will be duplicated and replicated across all our microservices. The main advantage for this is, you're going to have a consistent set of features for a single request, and also you don't have to go off and call the feature service to find out every time what feature is on. You can just check your headers, you got that information immediately. It's a lot more resilient and a lot more performant, as you aren't going off and keep hammering your feature service. The other thing that having good feature flags allows is, this is your enabler of separating the concept of your deployment versus your release. So you're continuously deploying code, and once it's out there, you can choose at your timing when you want to turn the feature on and for how many people you want to turn it on. So no more like complicated releasing of server pools, only 10% of change to server, 20% of change to server. If something goes wrong, rolling back all those servers. It's actually all done in your code. Just in like a control panel, or programmatically, you can just say turn this feature on for X amount of users and gradually scale it up. And if something goes wrong, you just flip a switch, the feature's turned off, and you're back to your old way of working, which you know has been working because it was always working right up until the feature was turned on. It was continuously being tested while being developed alongside your current system. So as I say, the nice thing about this is it gives you a very powerful rollback mechanism. So you're able to turn on features and roll back changes if your feature's not working as quickly and easily as possible. So as I said, when building new features, one of the things for us is your new feature shouldn't be replacing old code. It should be working alongside your old code. So this usually requires a bit of ingenuity and a bit of clever ways of thinking about how you go about developing stuff. So you might have to just take a slightly different approach or slightly tweak your code to have things living side by side, and then to be able to switch back and forth. But most time this is actually quite straightforward and is actually not that complicated. The whole time we've been doing it, it's been quite rare where this has been difficult. It's usually pretty straightforward to do. The next thing is your tests are highly important. So as you know, testing is important in continuous delivery, but if you're doing our approach of uncoordinated continuous delivery, your tests are extremely important, because this is how you can always trust your old ways working and how you build your confidence in why you're building your new way. If you can't trust your tests, it'll be really difficult to be able to trust this concept of working. But having good, robust tests that you can trust should just be part of continuous delivery anyway. So it should almost come out the bag for you if you're doing continuous delivery. But tests are very, very important in this approach. How we usually go about doing changes in backwards compatible manner is we take a simple approach of we loosen restrictions in order to do the backwards compatible change and have things living side by side. So say you're changing one field that used to be mandatory and you're changing, say, its name or a bit of its functionality, you'd make both those fields optional so they can live side by side, and then at the end, once you've flipped it on and you're doing your cleanup, you then can make the new field mandatory while deleting your old field. The trick here is that, as again I said, your tests are very important. So you'll be in these temporary states where you might not have the constraints you want in your system, but your tests will always be ensuring things are working the way they should. And actually, when the feature's on, these constraints are still being held, and when the feature's off, the old constraints will be held. Even though your code might not be that strict, your test should be making sure that happens. But as we know, things always don't go right, and sometimes you might not always be able to do something in a backwards compatible manner. So for us, as a last resort, that's where your versioning comes in. We don't really like versioning when we're doing things, because it usually means a lot of duplicate effort, and it usually means the cleanup is a lot bigger, because you have to copy a lot of similar functionality in order to do a small change, or in order to do a breaking contract change in your data and stuff. So we usually try to avoid versioning. So basically, use versioning when backwards compatible changes is rarely impossible. So this should be a last resort, and we should want to avoid doing versioning as much as possible. You just want this continuous, smooth, massaging and adapting of your system as you're continuously developing it. It's, instead of things being strict, it's going to be just constantly developing, improving, not like this is version 1, this is version 2 of our endpoints and stuff. It's just like your functionality is just slowly changing and morphing to meet the requirements of your customer. One of the biggest and most important things to be disciplined in this approach is actually cleanup. So doing all these things is you'll be taking a lot of small compromises, you'll be working a lot of temporary states, and if you don't do your cleanup, your technical debt can massively spiral out of control very quickly. So for me, you need to prevent your technical debt build up, because when you're doing continuous delivery, lots of small changes, if you don't keep on top of technical debt, it will spiral out of control. You think technical debt can get bad in a monolith system, and you're doing it in a microservice system, it just exponentially grows by the amount of microservices you have. But because everything's small and you're doing small changes, if you're continuously doing cleanup, you will actually develop a system that's better. So for us, we have it as part of our definition of done. So we might have released a feature all the way through to production. It might be working, fully used by our clients or our customers, but we don't actually consider it as complete or as done, was the work finished, until we've actually done our cleanup. So we won't actually mark the feature as done until we've actually completely finished cleanup. And the nice thing about this is, if you just have it part of your daily way of working, as part of your way of working, your cleanup won't actually be very big. It will always be just part of working, and you'll always leave your code in a much better state than you met it or started working on it. And also, your code base will actually be very healthy. So when you move to a new code section of the code base you might have not worked on, or you have new starters and new developers joining your team, they'll come to a pretty clean code base, so hopefully be able to easily to just jump in and get working quickly. So to actually sum up, what we have for us now at Ocado is we have a nice system that actually allows us on a day-to-day basis to we have 4 teams over 2 locations working on 35 microservices, and we're all able to just deploy our changes whenever we want, and it's not this massive coordinated effort to do this, and it's actually quite quickly, so we can actually get from the moment we deploy something to master, it's in production in under an hour, and we're always just continuously moving forward. And the main advantage we found when we look back, so if we take a step back and we look where Ocado was before we built our new platform and where it is now when we're building on our new Ocado Smart platform using these new principles. Before, we used to only do deployments every few weeks, so on our monolith system there used to be so much testing, so much manual testing, and it used to take ages to do a deployment. Now we do dozens of deployments a day. So in the space of a couple of years we've gone from deployments that were taken every few weeks, sometimes it could be a couple of months if there were problems, to dozens of deployments a day. Before, our deployments used to be really scary. There are dozens of stories, dozens of bug fixes. If something went wrong, what was the change that broke it? Where was it? But now we do dozens of small deployments. Our deployments just contain a small subtask, and if something goes wrong, we just know exactly where it is. And most of the time, it's nicely tucked away between us in a feature flag. If something goes wrong, we just flip it back. It makes those deployments a lot more risk-free and a lot less stressful. Also, as I was saying, we used to have required days of testing, lots of manual testing, and even that didn't used to catch problems. And now we have almost fully automated testing, and our code is quite stable. We quite rarely release actually breaking changes to production compared to before. So as I said, we used to have to always fix bugs. We used to do hot fixes before, so do this big monolithic release with these dozens of stories, which you didn't know how well they'd interact with each other and have these unforeseen consequences. And then you'd have to continuously do lots of hot fixes and doing lots of subsequent releases to just fix the actual release. But now we just have small bug-free deployments that happen quite rapidly. And the nice thing is, whenever we're about to release a brand new feature, in the old way it used to be this big scary thing, we're about to release this feature, and it used to be this whole day exercise of deploy it on a few servers, let 10% of users use it, let 20% deploy it on more servers, let more users use it. And it used to be this continuous big cycle. If something went wrong, it was this big pain rolling it back. But now we just do it all programmatically. We flip a switch, feature flag, let X amount of users use it, let everybody use it. If something goes wrong, we just turn it off and we're back to the old way of working and not this big massive rollback. Thank you.